LTPS has the same advantages as EXO, and in addition it allows to integrate the electronics with each pixel. Now, we are going to tackle the heart of the matter, namely the internal electronics in a gate driver chip. This chip contains a succession of electronic functions cascaded one after the other. Thus we find a shift register, a logic control, a level shifter, and a buffer. The shift register is an assembly of several electronic devices called a flip-flop. There are several models. Here will be used the flip-flop D. It has two inputs. A first input for the data named D, like data, and a second input, T, for the time controlled by a clock signal. The D flip-flop has two complementary outputs, one called Q, and the other Q bar, which takes the inverse value of Q. The operation is relatively simple. The value present at the input D, 0 or 1, is transferred to the output Q under the control of the clock, T. Depending on the setting of the flip-flop, the exact moment of transfer is made either on the rising or falling edge of the clock. The rising edge corresponds to the moment when the clock signal passes from 0 to 1. The falling edge is the opposite. Here is the table of operation of a D flip-flop. When the input D value is 0, the up arrow means rising edge of the clock. The output Q will be equal to the input, so 0 and Q bar is the opposite, it will be 1. When D is equal to 1, Q will be equal to 1 and Q bar will be at 0. The configuration of the shift register is done according to this diagram. Several flip-flops are connected in series. The output of each flip-flop is connected to the input of the next flip-flop. The information or data enters serially into the first flip-flop and leaves serially from the last register. The output of each flip-flop enters the next flip-flop, but the information also takes a second path which is parallel to the outputs of the other registers. Q1 coming from the first flip-flop constitutes the input of the second flip-flop. The output Q2 will be the input of the third register, and at the same time it will constitute an output which will go up in parallel to Q1. And so on. This assembly allows to store a binary data. In the gate driver, the D of the data will be the signal that allows the scanning of the lines to begin vertically. In short, it is noted STV, which is a contraction of start vertical. It can be found under the abbreviation VST, which is an inversion of the previous words, which gives vertical start. STV or VST is the V-sync, which is abbreviation of vertical synchronization. For the clock signal, the T is replaced by CPV, which is a contraction of the words clock pulse vertical.